Hi everyone, my name is Janahan Seelan and today I'm going to be talking to you about AWS Lambda. Lambda is a serverless technology that essentially allows you to run code without actually provisioning or managing any servers. And Lambda executes the code on your behalf, and it also scales automatically. It follows the pay-as-you-go model with AWS, so you essentially only pay for what you use, and there's no charge if your function is not being run. Lambda at its core is a set of runtimes, and these runtimes execute on virtualized infrastructure. And your functions are basically triggered by events. This is the function as a service model essentially, and I feel like it's the future of computing where the focus is on actually executing that service or that application as opposed to worrying about managing servers. So why Lambda? Well, I think the whole serverless model lends itself to a few different things. Firstly, it lends itself to a microservice architecture, which in turn is kind of aligned with the DevOps model and agile delivery. So if you're doing agile, you can really benefit from serverless, and Lambda is at the forefront of serverless. Lambda is also very scalable, so your function instances can be very concurrent. You can have up to 100 or hundreds rather of concurrent executions of your function. It is also redundant and highly available. Lambda is very simple in the sense that the service takes care of a lot of the ancillary services associated with executing your code. So things like security patching, running a web server front end to visualize the service, logs. All of these things are actually taken care of by the Lambda service itself. Lambda, when combined with other serverless technologies, can be quite powerful. For example, CloudFront or the AWS CDN solution, as well as things like DynamoDB, which is a backend database. When you combine Lambda with these other serverless technologies, you essentially reduce the number of moving pieces down to nothing, which makes it very powerful. So when should you use Lambda? So as mentioned before, Lambda is great for backend microservices. It's actually also good for event-based batch processing. So this is where you have a steady stream of events coming through, say for example images, and you want to execute some sort of algorithm or program across those images to reduce them or compress them. Lambda is really good for tasks like that. So just generalizing that, Lambda excels at short-lived event processing tasks. Now look at when you should not use Lambda. Lambda is a stateless model. It's a stateless technology, and as such, your code has to really follow the stateless paradigm, which makes it a little bit interesting in the case of where you lift and shift a monolith application from an existing data center. That sort of activity, particularly given that those monolith applications may be stateful and not stateless, it would make migrating to Lambda perhaps a little bit costly. Just sort of continuing on the pitfalls of Lambda, one of the biggest issues with Lambda is the call starts. And a call start is where if your function has been inactive for some time, it takes a little while to bootstrap that function, including its container. So call start can be anything from several milliseconds to a number of seconds, depending on what your technology is. And there's a special sort of type of call start that I like to call a VPC call start. And this is where your Lambda function sits within a virtual private cloud or a network. In this instance, it takes even longer to start up your Lambda function, perhaps up to about a minute. And so yeah, and another pitfall of Lambda is the associated costs with some of the events mechanisms. So, for example, API gateway, where you have hundreds or thousands of requests a second, the actual event streaming mechanism or the triggering mechanism of the Lambda function can become quite expensive. I'd just like to sort of focus on the cold start issue that we've just discussed, and I want to sort of propose a few strategies for mitigating cold starts. This is something that I've had to deal with in the past. The first strategy is what I like to call a persistent ping. This is where you consistently ping your Lambda function, thereby keeping it warm. So you can do this every minute, every couple of minutes. The second way of mitigating Lambda cold starts is just through app design. Imagine you have a very simple online retailing app where you have you have a landing page, and then you have some sequential steps, and then a checkout at the end. Well, if you design your app in such a way that perhaps the landing page calls out to your Lambda functions and warms them before the user has a chance to go through and execute those transactions, then that's certainly one way of keeping those Lambda functions warm. Another very easy way of improving Lambda call start times is just to give it more memory. That's a very simple way of increasing or reducing the call start time. And finally, Lambda has a new feature called provision concurrency, and this is where Lambda keeps some your functions active all the time, so they're hyper ready to respond. As mentioned before, Lambda has a bunch of native runtimes, everything from Java to Node to Python. But what happens if your Lambda runtime isn't supported? Say for example PHP. Well, in this instance, Lambda has a new feature called Runtime API that actually allows you to supply a custom runtime along with your function code. And then your custom runtime essentially manages your function code as well as the Lambda native interface. It's like the go-between. So it bootstraps your function code and things like that. And this is a really, really easy way now to get any runtime into Lambda. I'd like to just finish off by doing a quick price comparison between the AWS virtualized server instances as well as Lambda. So in this example here, we have what's called an EC2 instance, and it's a T2 micro, which has 1 GB of memory and 1 CPU. And we're comparing that virtualized box with Lambda, with a Lambda function that executes for 200 milliseconds, which has 1 GB of memory allocated to that Lambda service. So what I'm proposing here is a break-even cost. So when the required load on this function reaches 1.2 requests a second, that's when we break even with the EC2 costs. So that's 1.2 requests a second, or about 4,379 requests an hour. And before your function reaches this level of load, you're always saving money on Lambda. And if you have a look at a couple of other examples here, so we have a T2 medium, which is a bigger EC2 instance, and we have the same sort of memory and execution time for Lambda. And in this particular instance, because it's a bigger EC2 instance, our break-even point is 4.8 requests a second, or 17,516 requests an hour. So you can see that for an EC2 model to break even with Lambda, it has to actually be under quite a lot of load. And finally, we have a slightly larger EC2 instance here, and even there, we've given Lambda a little bit more memory, and even there, the break-even is about 2 requests a second. I'd just like to also sort of remind people that there is a free tier with Lambda, and it's 400 gigabytes of free Lambda processing per month, which is quite a lot. That is certainly generous, and that doesn't expire after 12 months. So that's actually all I have for today. Thank you very much for listening, and I'm John Hanseelan. Thanks.